Okay, welcome back. In this video, we're going to review the chain rule. The chain rule is a shortcut for taking the derivative of a composite function. Composite functions, recall, are functions that are plugged into other functions. The notation you would have likely seen previously is f of g of x. You have a composite function that is created by taking g of x and plugging it into f of x. And then the chain rule is a rule for taking the derivative of that composite. I'm going to use a different notation in this course. Instead of using f of g of x, I'm going to say it's f of w, where w is the same thing as g of x. It's just a different label for it. So if y is f of w, then y prime will be f prime of w times w prime. That's the statement of the chain rule. We take the derivative of the outside function and multiply by the derivative of the inside of the function. Another way to write the chain rule is to say that the derivative of y with respect to x is equal to the derivative of y with respect to w multiplied by the derivative of w with respect to x. This format is nice because if you cancel the dw's top and bottom and think about these as fractions, you get dy by dx on one side and dy by dx on the other side. So it has that nice feature. There's some other benefits to using this notation that will be apparent later on as we move through the course. So I'm going to do the derivative of these two functions using the chain rule and using this w notation. And the w notation is likely new to most of you. You're likely, instead of writing it this way, you're probably used to seeing d by dx of f of g of x is equal to f prime of g of x times g prime of x. This is probably what you're used to seeing because it's the most pervasive notation inside high school level calculus textbooks. I'm not going to write it that way. I'm going to write w instead of g. So I'm just comparing this one to this one. They're pretty much the same, just replace one letter with another one and suppress the bracket x notation so it looks a little bit cleaner. Just cleans it up a little bit. Excuse me. Okay. First problem on this slide. The first step is not to take the derivative. The first step is to just replace everything in the brackets with the letter w. W to the power 4. Now we'll take the derivative. F prime of x is 4w to the 3 times w prime. So going back to here, the 4w to the 3, that's the f prime of w, that's the derivative of the function with respect to the variable w, treating w as if it was an x, multiplied by w prime, by the dw by dx. Now I'm going to undo that replacement, that letter substitution. I'm going to put w back the way it was. 4 times 3x squared minus 5x to the power 3 times w prime. Well, what's w? W, we said, was everything inside the brackets. 3x squared minus 5x. So w prime is going to be 6x minus 5. So that's what will go here. And that is usually good enough. We can simplify, it's possible, but this is I think the best way to write it. It's clear that the 4 came down, the power got reduced by 1, and that the 6x minus 5 can clearly correspond to being the derivative of the inside. The next one we're going to do the same way. I'm going to start by calling this square root of w, and then saying, wait a second, that's just w to the 1/2. So we can use a power rule for part of our chain rule. Now take the derivative. So the 1/2 will come down. We'll have w to one lower power. So 1/2 minus 1, which is negative 1/2, multiplied by w prime. So 1/2, I'm going to replace the w by 3x squared minus 5x, power negative 1/2. And then we're going to have to find w prime. W is 3x squared minus 5x. W prime is 6x minus 5. So that'll go here. And that'll be your answer. There's rules, there's derivatives where you have to combine rules. So combination of a product rule and a chain rule, or a combination of a quotient rule and a chain rule. This is that case. This is a combination of a quotient rule with a chain rule, and there's a few ways to do it. I'm going to show you the easiest way. The easiest way is to start by saying, or by kind of doing what we did in these problems, by saying we have a function raised to a power, and I'm going to replace the thing that's being raised to the power with the letter w. And it doesn't matter that thing is a fraction or not. It's just it's a more complicated w, but it's still a w. This is w to the power of 6. Now when we take the derivative, it's 6 times w to the 5 times w prime using the chain rule. 6 times 3x plus 1 over 2x minus 5, all power 5. And now we're going to have to find what w prime is. W is equal to 3x plus 1 over 2x minus 5, which is the top function over bottom function. W prime is going to be the bottom times the derivative of the top, minus the top times the derivative of the bottom, divided by the bottom squared. So bottom function, 2x minus 5 times t prime, which is 3, minus the top, 3x plus 1, times the derivative of the bottom, which is 2, all divided by the bottom squared, 2x minus 5, all squared. And that can get plugged in up there. (2x minus 5 times 3) minus 3x plus 1 times 2 divided by 2x minus 5 all squared. And that'll be your answer. It's kind of messy, it's kind of yucky, but it's mechanical. You don't have to think very much. You think, all right, this is a function to a power, so I use that special chain rule. W prime, W is a quotient, so I need a quotient rule for that. Just keeping track of all the rules that you need to use to take the derivative. This next one is also a combination. Notice that it's two, like this is kind of the initial struggle when you're doing derivatives, is figuring out what type of template to use for the function. Like what type of derivative is this? And the easiest type to miss, I think, like quotients are kind of obvious. You see the fraction, you think quotient rule. Chain, you see a function to a power, kind of easy to see. Product tends to be the one that most students have the highest risk of missing. Two functions multiplied together means you need a product rule. There are definitely two distinct functions multiplying each other here. The first one, which I'll call A, is the 3x minus 1. The second one, which I'll call B, includes the power 6 on it, 2x squared plus 5, all power 6. When we take the derivative of the first function times the derivative of the second, plus the second function times the derivative of the first. So that's a times b prime, 3x minus 1. I'll leave a space for b prime, plus b, 2x squared plus 5 to the power of 6. Leave a space for a prime. You need less space for a prime. And then calculate those off to the side. A is equal to, I'll put b down here. B is equal to 2x squared plus 5 to the power of 6, which is w to the 6. So here's our second rule. We need a chain rule. B prime is going to be 6w to the 5 times w prime, which is 6 times 2x squared plus 5 to the power of 5 times the derivative of the inside, 4x plus 0. So I'll just put that up in the box. Six times 2x squared plus 5, power 5, times 4x. I'll drop the plus 0, mostly because I'm running out of space. And then a is equal to 3x minus 1. We don't need any special rules for that. The derivative of a is just 3. And that's it. That's our answer. I did those calculations off to the side, the b prime and a prime calculations, and plugged them in. Okay, test style examples. These are questions you have to think a little bit more about, where you're given some data, you're given some information. It's all the same rules, it's all the same product, quotient, and chain, and all those things. So suppose you're told that what f of 4 and g of 4 are equal to, and f prime of 4 and g prime of 4 are equal to. You're given that data, and you're asked to find the slope of a tangent line to a curve at x is equal to 4 for each of the following functions. So the first thing you have to do is you have to know what that means, slope of a tangent line. You have to know that it means find the derivative evaluated at the x-coordinate. So we want h prime evaluated at 4 for each. That's what slope of a tangent line at x equals 4 means. So let's take the derivative. For part A, h prime of x, we have a constant multiplied by f of x. When we take the derivative, the constant just waits outside and says, hey, I'm just going to not get involved until you're done. The derivative of f is f prime. The next part, it's just added together. We don't need a product or anything fancy. It's just two separate derivatives because these pieces are separated by a plus sign. 3 times g prime. Now we're going to get the slope at 4. So 2 times f prime of 4 plus 3 times g prime of 4. We're going to plug in our data. 2 times negative 1 plus 3 times 3. Negative 2 plus 9 is equal to 7. So that's our first answer. That's the slope of a tangent line for the first function, for the first h of x. Part B, now it's a different function. We were asked for the derivative of 3f of x times g of x. I'm going to call 3f of x, I'll call that a. I'll call g of x b. And then when we take the derivative, we have a times b prime plus b times a prime. So that will be 3 times f of x times g prime of x for b prime plus b, which is g of x, times 3f prime of x, taking the derivative of 3 times f. It's 3 times f prime. Now we want the slope by evaluating this at 4. We'll plug in our data. So 3 times f of 4 is 5, times g prime of 4 is 3, plus g of 4 is 2, times 3 times f prime of 4 is -1. So we'll have 45 minus 6, which is 39. That's the slope of the tangent line for that function. Now for the last one on this slide, this is the top function over a bottom function. So when we take the derivative, we'll have bt prime minus tb prime all over b squared. So this one's going to be tougher. So our bottom function is just f of x. For t prime, t is equal to, let's use a different color, use green. T is equal to 3x times g of x. T prime, we need a product rule. Well, the first function, 3x, times the derivative of g, plus the second function, g, times the derivative of 3x, which is 3. So that'll go up there. 3x g prime of x plus 3g of x minus the top function. So the top function is 3x times g of x times t prime. So this is the minus tb prime part. B prime, the derivative of the bottom, is just f prime of x, all divided by the bottom squared, by f of x, all squared. Now we'll get the slope. H prime evaluate at 4, which is going to be f of 4 times 3 times 4, since we're replacing all the x's with 4s, including that x that's there, times g prime of 4, plus 3 times g of 4, minus 3 times 4 times g of 4 times f prime of 4, all divided by f of 4 all squared. This is not going to be very nice. Got some yucky numbers. So f of 4, 5 times 3 times 4 times g prime of 3 times 4 times g prime of 4 is 3, plus 3 times g of 4 is 2, minus 3 times 4 times g of 4 is 2, times f prime of 4 is -1. All divided by f of 4, which is 5 squared, so 25. Okay, so I have 3 times 4 times 3, 36, plus 6, 42, 42 times 5, 210, 210 minus or plus 210 plus 24, 234 over 25. Double check that. Find any, if there's a mistake, please let me know and I'll correct it. I won't correct it in the video, I'll correct it in the notes. But, man, I didn't mean that one to be that bad. My apologies. The next one should work out better. It should. I spent more time thinking about it. Next one is with the same construction, with the same data about f of 4, g of 4, f prime of 4, g prime of 4. Our new function h of x is a chain rule question now. G of f of x minus 1. So my first step is I'm going to replace everything inside the brackets with a w. So this is g of w. This is a chain rule. When we take the derivative, we have to think about the chain rule notation that you're more familiar with, the one that you would have seen in your high school calculus course. G prime of w times w prime. Which is g prime at f of x minus 1 times the derivative of f of x minus 1. So w is f of x minus 1. W prime is f prime of x minus 0, since 1 is a constant, its derivative is 0. So this is just f prime of x. Now we want the slope. M is equal to h prime evaluated at 4. So it's g prime of f of 4 minus 1 times f prime of 4. So this is g prime. Now what is f of 4? F of 4 is 5. So 5 minus 1. What is f prime of 4? F prime of 4 is negative 1. So I have g prime at 4 times negative 1. G prime of 4 is 3. So 3 times negative 1. And the answer is negative 3. Very nasty. You have to know the chain rule in the most general format. So if you have a composite function, a function of another function, the derivative of that is the derivative of the outside piece, the g prime, evaluated at the inside, multiplied by the derivative of the inside. And you can flip back to the formula and see this is just that chain rule formula written out in a situation where you'd have no alternative. You have to use the general case of the formula. Okay, and one more, I think. Oh, two more. Suppose now that we have a function f of x that's equal to x plus 2 times h of x all raised to the power of 3. We want to find the equation of a tangent line to this function at x equals negative 2, given some information about h of x. So I'm going to rewrite the question. And then recognize that this is a chain rule problem. To take the derivative of this, I'm just going to replace everything in the brackets with a w. So I have w to the power of 3. Now we'll take the derivative. F prime of x is 3w squared times w prime. So 3 times x plus 2h of x all squared times w prime. So what's w? W is equal to x plus 2h of x. W prime, the derivative of x is 1. 1 times x is 1, derivative. And the derivative of 2h of x is 2h prime of x. So we'll put that in. Now what we want is we want the slope first of the tangent line. So this is kind of a step one. Find the slope of the tangent line. M is equal to f prime of x evaluated at -2. So that's going to be 3 times -2 plus 2 times h at -2, which is 3, all squared, times 1 plus 2 times h prime of -2, which is -1. So we'll have 3 times 4 squared, so 3 times 16 times -1, which is -48. So there's our slope, there's our m. Now we need the y value because it's asking us for the equation of the tangent line. So that'll be f evaluated at -2. So that'll be -2 plus 2 times h of -2, which is 3, all power 3. So that'll be 4 to the power of 3, which is 64. And then step 3, combine them. Y minus y1 is equal to m times x minus x1. So we'll have y minus the y coordinate, y minus 64, is equal to m, -48, times x minus the x coordinate. Subtract -2. And then we can simplify. Y minus 64 is equal to -48x minus 96. And then add 64 to both sides. So -48x. And then let's see. So I add 4, so -92, add 60, -32. Please double check that as well. I have problems with adding and subtracting. Mentally, without paper. And that would be our answer. So it's a very involved question. Chain rule, let's take the derivative. We don't actually have the functions, we just have data about the functions. So when it comes to time to evaluate the derivative, we have to use that data. And then we have to find the y value and plug everything into the equation of the tangent line. So lots of stuff going on. Now the last example, suppose we have 3 functions of x, given by k of x, c of x, and n of x. We're given some data. We're told that k evaluated at 0 is 1, c evaluated at 0 is -1, n evaluated at 0 is 0, and k prime evaluated at 0 is 5. If f of x, so this is now a 4th function is involved, is equal to k of x plus c of x times n of x. If this function has a horizontal tangent line at x is equal to 0, find the value of n prime at 0. The stuff of nightmares. This is a hard question, but once you know how to do it, it's not that bad. I'll show you how. We have to pick apart a few statements here. One statement is one we haven't tangled with yet this year, this term. You've probably, or I shouldn't say probably, you definitely, in your previous calculus course, would have been subjected to the language of horizontal tangent line, or at least the idea. Maybe you use different vocabulary, but you would have talked about horizontal tangent lines as tangent lines that have a slope of 0. So a horizontal line going left and right, that slope, the delta y over delta x, is a slope of 0. Slope m is equal to 0 means f prime of x equals 0. That's all. So we're looking for the x value. We're not looking for the x value that causes the slope to be 0. It's just telling us that the derivative at that point is 0. That's all. We're told that it has a horizontal tangent line at x is equal to 0, so actually it's better than that. It's f prime of 0 is equal to 0. So let's take the derivative of everything. So I'll take the derivative of the first piece. The derivative of k of x is just k prime. Nothing weird's happening there. It's not multiplied by anything. Plus, we have a product rule. We have an ab prime plus ba prime. So f prime of x is equal to k prime of x plus a is c of x. And then b prime, the derivative of the second term, is n prime of x, plus b is n of x, times the derivative of the first part, which is c, so c prime of x. Not so bad. Now we plug in our data. So we're told the slope of the tangent line is 0. So 0 is equal to f prime of x. So I'm going to do that. We're told, actually I'm going to plug in the zeros. I'm going to say f prime of 0 is equal to, we're asked for n prime of 0, so I'm going to evaluate all these at 0. C at 0, n prime of 0, plus n of 0, c prime of 0. Now start replacing everything. So after, oh, no. 1 second. Okay, so let's plug in the data. We have f prime of 0 is equal to 0, since it tells us that the function has a horizontal tangent line there. Then what else do we have? K prime of 0, that tells us is 5. I'll put a 5 there. C at 0 is -1. So I'll put a -1 there. N prime of 0 is the thing that we're after. Plus n of 0 is given as 0. Am I running out of colors yet? Might be running out of colors. And then c prime of 0 is not given, but it doesn't matter. C prime of 0 is being multiplied by 0, so whatever it is multiplied by 0 is going to be 0. So I have 0 is equal to 5 minus n prime of 0 plus 0. I'm going to add n prime of 0 to both sides. N prime of 0 is equal to 5. That's it. So it's a challenging question in that you have to think about what you're doing. You have to know your derivative rules, that there's a product rule that's involved. You have to know what a horizontal tangent line means. It means that the slope is 0. You have to not give up, because you might look at it and say that I don't have what c prime of 0 is equal to, so the question is impossible. There's a lot of roadblocks, a lot of barriers. It's definitely a hard problem. It's not like a standard question, and it's very unlikely that anything that's called test style example that you've seen in the week 1 notes, it's very unlikely that you've ever seen anything like it before, and that's fine because it's a university level calculus course. It's not a high school level calculus course. See you next time.